Hello everyone, my name is Rajkumar Jaiswal from Acropolis Institute of Technology and Research, CSE department, and I am here to tell you something on vector similarity search and its evolution. So now first have a look at the content what we will be seeing in this video. So first we will see the definition of vector similarity search, then we will see the components in it. Then we will see nearest neighbor search and k nearest neighbor. Then we will see the usage and example of vector similarity search and how we can use vector similarity search in improving security measures and develop deep learning algorithms more quickly. So now let us first start with the definition of vector similarity search. So as you might guess from its name, a vector search involves representing pictures or bits of text as vectors or embeddings. They often help train machine learning models. Object similarity also comes into play, which compares the vectors in a multi-dimensional space. A vector search involves representing pictures or bits of text as vectors or embeddings. Vector similarity search is also known as nearest neighbor search or simply vector search. Now let us look at the components of vector similarity search. So there are typically four components to a vector similarity search. The first is vector embedding. So vector embeddings capture the key characteristics of the original object, such as a song, an image, or some text. The second is distance matrix. It represents nearness between two vectors. The next is search algorithms such as KNN, and the last is database. And database holds the vectors and supports the vector search with indexes. So now let us have a look at the nearest neighbor search. So nearest neighbor search, NNS. So what is this? It is the optimization problem of finding the point in a given set that is closest or most similar to a given point. Closeness is typically expressed in terms of a dissimilarity function. The less similar the object, the large the function values. So the next is k nearest neighbor. Mm, A k nearest neighbor, KNN. Search finds the k nearest vectors to a query vector as measured by a similarity metric. In general, a k nearest neighbor algorithm gives good answer to vector search problems. Only the major issue with KNN is that it's computationally expensive, both in processor and memory usage. So now let us see the uses of vector similarity search. The first is vector search is the technology which is used in various Google search, YouTube, Google Play and many more such as Facebook, etc. This technology is one of the most important components of Google's core services, and not just for Google. It is becoming a vital component of many popular web services that rely on content search and information retrieval accelerated by the power of deep neural networks. Although this technology is still in the very early stages, as more companies decide to use it, the potential application will become even more evident and exciting. So now let us look at the example of vector search. So vector search uses vector for representing and searching content. And here vectors is a list of numbers. The combination of numbers defines similarity to specific topics. For example, if an image includes 10% of movie, 2% of music, and 30% of actor related content, then you could define a vector 0.1, 0.02, 0.3 to represent it. So now let us see how we can use vector search similarity to improve security measures. as you all know that maintaining a high level of physical and cyber security is vital for today's business to succeed. For example, vandalism or product theft could cut into profits, while a ransomware attack could lock company representatives out of critical systems and data. So, a vector search engine could store data about people who have stolen from a store previously, allowing an algorithm to recognize possible problematic shoppers. And computer codes could also feature in vector similarity searches. According to GSI technology, checking a piece of software against a database of known vulnerabilities could tell a company whether the product has issue for hackers to exploit it or not. So now let us see how we can use vector similarity search to develop deep learning algorithms more quickly. So vector similarity search relies on deep learning, which is an advanced form of artificial intelligence based on how human brain process information. There is a growing push for business of all types to see how AI could help them. For example, statistics shows it's possible to get up to 20% conversion cost reduction when applying AI to core business practices in producing industries, according to Blue Senti. However, many companies don't have people on their teams with extensive AI knowledge, and it's not always easy to find such specialists quickly. And thank you. Thank you for watching.